Okay, I hope by now you have figured out all the subsets and counted them up. So in general, we actually have a formula for doing it. How many subsets are there? Okay, so if you have n elements in a set, okay, you would have 2 to the n number of subsets. That equals the number of subsets. Okay? So in our case, we had 4 elements. 2 to the 4. That simply means 2 times 2 times 2 times 2, 4 times. 2, 4, 8, 16. So if you did it properly and you added up everything we had, okay, it would be 16 subsets of that group of 4. Okay? And as I said before, if you had, 6, 8, 10, that's a huge, huge number. 2 times 2 times 2 times 2 times 2. In fact, if you tried it on the calculator, your calculator would overflow. You wouldn't even get an answer. Not a real answer. It would be an approximation, perhaps. Okay, so that's how many subsets. So if I ask, well, how many proper subsets are there? Well, we said the proper subset was really a subset with one exception. The full set was not included. The A equals B, that was not excluded. So the number of proper subsets is going to be 1 less than the number of sets, equal the number of proper subsets. Okay, that's the number of proper subsets. All right, so we have a way of calculating how many there are. It doesn't tell you what they are. Okay, it just tells you how many there are. Okay, so that's valuable sometimes. Depending what the problem is, comes out a lot in probabilities. Probability statistics, sometimes you just have to count things. And there are other ways of counting more complicated things as well. Okay, let's talk about complements. You're looking lovely today. Oh, not that kind of complement, the mathematical complement. Okay, so if I have a universe, which I can show as a box, everything is included in the box. Okay, call it U. That is my universe. Okay, if you like, think of it as a fish tank, just think of it as a rectangle. In that, I have decided that I'm going to show all my elements. Okay, so if this is element or set A, with however many elements are in there. Okay, that's set A. The complement of A, written like this, okay, is the set of elements, or we said members, right? Set of members, elements, in U, but not in A. So A complement means not A. Okay? So if I was to shade the not A area, this all out here would be the not A area. Okay? This is not A. A is inside, everything on the outside is not A. Okay? So that brings in a whole area of how we represent things when we're trying to logic out some complicated representations. And these diagrams sometimes help us do things that we couldn't do otherwise. Okay, and in general, we have a name for these diagrams. You might have heard of it before. They're called Venn diagrams, named for the person who created it, Dr. or Mr. Venn. Okay? That's happens when you don't turn your phone off. I apologize. Okay, please turn your phone off, class. Okay, back to work here. If we have the universe, okay, and then we have A represented as set A, and B represents set B. Now I'm drawing it this way, but I don't really know at this time that there are elements in common, which would be the overlap area. That area in common may have no elements in it, But it doesn't hurt to draw it that way because it allows me to consider that there are some in A that are also in B, and some in B that are also in A. It may not be, so that could be an empty area, but for now we're going to do that, and that's typically done until you know better. Okay, so that's your set A and your set B, and we have some terms we have to know when we talk about the Venn diagrams. So the area where they're in common in diagrams, that is called intersection. It's just like in a road, you have road intersections, okay, where two streets come together. Okay, Market Street overlaps Broad Street. Bad example, there's City Hall right in the middle. Okay, where Chestnut Street crosses 15th. That would be an intersection of two streets, and the area in the middle is called the intersection. Okay, so you have that area of intersection or overlap, and that represents the elements in A and B. Okay, those are the elements in A and B, and it's written as A intersecting B. Okay, an upside down U. A intersects B, that's shown over there, and that's the intersection of the two sets. What would that mean, for an example? Supposing I had my high school class, some of my students were on the football team, and some were on the basketball team, and some were on both. So I could have 5 in this group, 7 in this group, and 2 who did both. Which means 9 people play football, 2 of which also played basketball. 7 people play basketball, 2 of which also play football. In total, we're talking about 14 students, right? 5, 2, and 7. There are 14 students in my group of athletes, okay? And there are 9 and 7. 9 and 7, 9 plus 7 equals 16. But wait a minute, you said there were 14. Yes, I did say there were 14. You don't count these people twice, okay? If you're ordering uniforms, yes, they'll get a football uniform, and if they're going to play basketball also, they're going to get a basketball uniform. So yes, as a budget officer, I might say I need 16 uniforms. But how many people are involved, okay? The number of people involved are 14. That's 14 people. This is uniforms. I hope you can read that. At least if you can't read it, you can hear me say it. Okay, 16 uniforms and 14 people. Okay. Okay. All right, so that's what we mean by intersection. Intersection means they are in both. Okay, that's clear, I hope, but we're not done. No, we're not. We also have a case of combining both. Okay, suppose you're given that 15 students do drama, they're in the drama club, 13 are on the newspaper staff, okay, and 4 do both. Okay, so this is a total of 15 people in drama, a total of 13 people on the newspaper staff, and from that whole mix, 4 of them are on both. So the question is, HM, how many do only drama? And I could also ask how many do only newspaper. It's going to be the same thing. It'll probably come out in the wash here. Okay, so let's make a Venn diagram, because if I just asked you that question off the cuff without knowing Venn diagrams, you'd have a fun time playing with it. Maybe you'll get the answer, maybe you won't. So knowing how to work with Venn diagrams, you'll always get the answer. Okay, so let's look at what we have here. So we have a total of the drama, and the newspaper. Okay, a total of 15 in drama, and a total of 13 in the newspaper. Okay? But how to start? Where do you go? Well, the way you start is look at the overlap. This is the most specific piece of information we have. We know that 4 do both. Okay? Well, let's look at it now. If 13 are in the newspaper all together, and 4 are also doing something else, how many are only in the newspaper? Okay? 13 in the newspaper, 9 minus 4, of which of the 13 are also doing the other thing, the drama. Okay, that leaves 9. So that means you have 9 here who are only, okay, only newspaper. 4 here, together they make 13. Okay. What about here? We know of the drama people, 4 also work for the newspaper. So that leaves 11 in this section here who only do drama. Well, that was the question, right? How many only do drama? There's your answer. Okay, 11. Okay, that's a very methodical method. You know, that's repetitive. It's a very clear method for attacking these problems, and they can be with multiple clubs. It doesn't have to be 2 or 3. It could be more. But let's do another one. Let's now talk about the case of the union of 2 sets. Union of 2 sets. That would be the case where if you had an A and a B, the union would include all of the sets, all of the elements that are in A or B or both. And that's an important definition. All elements in A or B or both, just to be perfectly clear. Okay? So, an example of how that might come in handy. Okay, let's look at an application. Suppose we have our universe of students, and a certain number of them have Twitter accounts, they're active Twitter users, and a certain number of them are blog users. Okay, so if we know, okay, that there's a situation where there are, say, 25 students who use both Twitter and are bloggers, there are, say, 35 people who only use Twitter, and there are 10 people who only blog. The Twitter, okay, union, written this way, union, blogger, called B, that equals the combined number, okay, that equals the people in all of those, and we'll say that the dimension, the cardinality of this, how many members there are, would be the 35 plus the 25 plus the 10, okay, and that would be 70. All right, so the union of all of those would represent those who are only bloggers, those who are only bloggers, only Twitter account users, and the group that does both. And that's the case of union. If you looked at intersection, that would be just the 25. Union is written with a U, a big U, indicating that it's the joining of the 2 sets and the members of it. Okay, we'll do some applications with that later on, but the indication is the U as opposed to the intersection, which we use the upside down U.